Now let's move on. What are the dimensions has he given me? He's given me AB is equal to 1500 mm long. Now it is 1500 mm is the length of the connecting rod. Now the next thing, crank AO. He has given me 225 mm, and it also told me to determine the travel of the slider. So let's move. The first step, what we are going to do? Any guesses? Nobody is there. So let's see. The first thing that we want to do is we want to draw the reference lines. Reference lines of what? We want to draw the reference line of the rotation of crank. We want to draw the reference line of the the reciprocation of the slider. So here we go. This is line L1. On this particular line L1, I will have my particular crank that will be rotating. This is line L2. On this line L2, I will have my slider, and L1 and L2, the distance between them is 300 mm as denoted on the left hand side. Okay, now it is clear that this particular line is for the crank to rotate and this particular line is for the slider to oscillate. The next is, I'll take a point where my slider is going to rotate. The axis was O, so I mark it as O. This is the center of my crank circle or my crank wheel, or this is the center about which my my crank is going to rotate. So I have taken a point O on L1, which is the center of my circle, the crank circle. Now the next step, what is my next step? Now I have my O, so I will draw the crank circle. As we did in the previous question, I will have my crank circle, because I should know how far will be my crank and how it will be rotating. So I will take my radius as AO, that is 225 mm, which is equal to the length of the crank, and I will draw a circle. Now next, I have my crank circle, so I'll take any radius and I will draw my crank. AO is my crank that will be rotating. Now the next step, what will be my next step? With center as A, as we did in the previous question. What I have my position of A. Now for that I need my position of the slider. For that I need to know that where the connecting rod will be, where will be the initial point of the connecting rod and will be the final point of the connecting rod, because A will be the initial point of the connecting rod that we know. The final point of the connecting rod will be connected to the slider, the center of the slider. So if I have the length of A, length of the connecting rod from A, from the path of the slider, so I will have the slider position. Now in the previous question, the difference that is there in the previous question and this question, that the arc, the radius we have taken already, the 1500 mm we have taken the radius, and we have put the pointed end of the compass on A, and now we have to mark the arc. Now in the previous question we knew that the axis of rotation of crank and the reciprocating slider are both on the same line. That's why we took the radius equal to the connecting rod and we cut an arc on the particular line on which both the things were oscillating and rotating. Now what is the difference between that? Between that problem and this problem, there is only one difference. The arc, instead of cutting the arc on line L1, we are going to cut the arc on line L2. Why? Because my slider will be reciprocating on line L2. So I will have my different positions of the slider on L2. So with radius equal to the connecting rod and my center as A, I will cut an arc B on line L2. This is my particular initial position of the slider. Now let's again, I will draw the connecting rod AB, and then I'll make the slider of appropriate dimension, again which is not mentioned in the question, that how big the slider. So I'll take normal sizable slider to show that okay, this is the slider. So here we have the slider and crank mechanism ready. Offset slider and crank mechanism. Okay, so it is ready. Now we should know what we have to do. We have the mechanism. Now again the same old story has to be repeated. There is going to be a point on the connecting rod as it given the question. As you can see, plot locus of a point P 450 mm from A along AB. So AB is this, A is this. So it is going to be 450 mm away from this particular point A. So what I will do is, I will again take radius equal to 450 mm. Why 450 mm? Because the point P is 450 mm away from A. I'll put my pointed end at A and cut an arc at AB and mark it as point P. Correct? So this is the point for which I have to draw my locus. Now let's see, what are we going to do? The next thing, as we did in the last question, we are going to mark 12 different positions of the point A, or say crank, on the crank circle. For that I need to divide, again the same thing I need to do. I told you it is very important to know how to divide a circle in particular number of parts. Again I'm going to divide my crank circle OA, this crank circle, into 12 parts. For that I'll follow the same procedure that I did. I'll first say what angle I have to take. 360 degrees is my total angle. How many parts I have to divide? 12. So 360 degrees divided by 12 is 30 degrees. So my each angle has to be 30 degrees. Each segment on the circle has to be 30 degrees away from each other. So again what I'll do, I'll take my protractor D, as we say, keep the center at O, the base AO, and mark A1. Okay, then here I have not shown the steps because we did it already. So I'll do that. Then I'll again take the distance A1, keep my point at A1 and cut an arc at A2, and that will go on and on and on till A11. So these are different points of my crank at different times. For now again I have to mark different positions of the connecting rod according to that, different position of the slider according to that, and different positions of P according to that. And once I'm done with that, I'll connect the points to get my locus. Here we go. Now with radius equal to the connecting rod, that is AB, I'll put my pointed end at A and cut an arc at B1. Connect A1 B1, then mark point P1. Similar, how did I mark point P1? I'll take distance is equal to AP on my compass, put my pointed end at A and mark my point P1. Now again the same thing I'll repeat for A2, A3 till A11. I'll mark B1, I mark B2, then I will connect A2 to B2, then I'll mark my point P2. Again I'll repeat once again. What am I going to do? I'm going to take the radius equal to the connecting rod, put my pointed end of the compass at A2, cut an arc on the line L2, that is the line on which the slider is oscillating, mark it B2. Now the next step is take radius is equal to AP, put my pointed end at A2 and cut an arc on P2. This same procedure will follow for A3, A4, A5, A6, A7, A8, A9, A10 and A11. So again we can see that we have all the points in association with the position of the slider, the position of the connecting rod, the position of the crank. Right from A till A1 we have B for crank positions A to A11 we have different positions of the slider from B to B11, and at the same time the position of P is determined by the red markings or the arcs which are cut on the connecting rod from P till P11. So again what I'll do is I'll draw a smooth curve which passes through all the points from P1 to P11. Here we go. To get the locus, I'll join the points P1 to P11, and here I have the required locus of this particular question. Now again I'll give you one application of this. So this is a very complex structure. This is used in oil rigs, this is used in different kinds of combustion plants. It is oscillating. The crank, this is the crank, we are going to consider this as crank, and this is oscillating, but basically it is rotating about this particular point. So this is the axis of my rotation of crank. And what is this? This is a slider. This is a slider. Both these are sliders. What they are doing, they are moving according to this particular crank because this is the connecting rod that is making them move. So this is an example of an off slider and crank mechanism. This is the crank which is oscillating, this is the connecting rod, and this is the slider which is oscillating, and this is my crank. So this is the slider, this is the slider, this is the connecting rod, and this is my crank. So we have come to the end of this session, but don't go anywhere. After a few minutes we are going to discuss two more problems. One is 4-bar crank mechanism, and the other is a pendulum on which there is a disc that is rotating. So these two exciting problems are going to come in this coming session, that will be after a short break. So be with me, don't go anywhere.